everybody, we are in 5.3. This is all things algebra, the Circumcenter and Incenter. I just finished with part 1, which was a little tutorial Pythagorean theorem. I'm not really sure why they placed it here, because typically you have learned this already. You'll get a really good detailed version in Unit 7. But here we are. I'm going to turn the page and I'm going to go straight to Circumcenter. Well, you guys, a circumcenter is made from perpendicular bisectors, and in a triangle you have 3 of those, one for each side of the triangle. One for each side of the triangle. So the perpendicular bisector of the sides of a triangle intersect at a point called the circumcenter. So this is a perpendicular bisector. Now, if you have forgotten what that is already, then shame on you. I told you in multiple videos that once you learn something in geometry, it's not going to go away. But I love you enough to tell you what it is. So every triangle has 3 sides. Let's look at this side AB right here. A perpendicular bisector will cut that side in half. That's what a bisector does. It hits the midpoint or finds the midpoint. So D is the midpoint of AB. That's the the bisector part. But the perpendicular part means that it forms a 90-degree angle. And I think there is why they were making us go through Pythagorean theorem, because these all are right triangles. But there you go. The circumcenter is always equidistant from the sides. All right. Oops. This is what creates the circle around the outside. It's the angles. All right, use the diagram to the left to answer the following questions. List the perpendicular bisectors. All right, well, that would be DP, EP, and FP. And name the circumcenter, that would be P. And list all congruent segments. Oh gosh, really? All right, BD is congruent to AD. BE congruent to CE. CF congruent to AF. Okay. Yeah, whatever. Let's look at number 1. Okay, what's going on here? All right, it says find the measure using the information given. Okay, Z is the circumcenter of triangle TUV. Okay, so they want TU, VY, UZ, WV, and TV. Good Lord Almighty. Okay, I think what I'm going to have to do is kind of just go through first. TW and VW will be the same. VY and UY will be the same. Now the whole thing's 34, so half of 34 will be 17. TX will be the same as UX, so that TX is going to be a 19. Oh gosh, TU, 19 on the left plus 19 on the right. What's 19 times 2? 38. Should have known that. Okay. VY was the 17. What do they want? UZ. Where's UZ? Okay, UZ is that segment right there. Okay, don't have that yet. WV. Looks like I don't have that one yet. And TV, where's TV? Okay, I don't have that one yet. All right, well, I'm going to now see why they had us do a Pythagorean theorem, because that's what I'm about to have to do. There it is right there. I just got it out of my mouth, and we got to find WV for this one, and then TV, which is the double version of that. And I'm looking at this right triangle in order to do so. So here's the thing. I'm thinking this is the 21 right here, because otherwise they would have put the number on the outside if they wanted it to be WV. So I'm going to do the Pythagorean theorem. X squared plus 15 squared equals 21 squared. And this is going to get me what I'm pointing to, WV. All right, so now I see why they had us do the Pythagorean theorem in part 1. That all makes sense. All right, so 21 squared minus 15 squared. And then what you get, you're going to square root that. So 216, and then the square root of that is approximately, what do they want us to round to? It doesn't say. So approximately 14.7. So UV is approximately 14.7. I'm sorry, WV, my bad. WV is approximately 14.7. Now they want TV, which is double the 14.7. So I'm just going to hit times 2. And that's going to be 29.4. Remember, it's the number after the 3 that tells the 3 what to do. It's a 9, so it's going to make a 4 right there. So 29.4. And I got to find, what else I got to find? UZ. Okay. Okay, so let's see here. Well, since circumcenter is the same distance away from each angle, and the distance from Z to V is 21, that means the distance from Z to U is 21. And I can find WZ just by knowing that. So 21. Okay, there we go. I was thinking how to do another Pythagorean theorem. I keep thinking I'm doing centroid, and yeah, that's why I messed up earlier on that circumcenter is always equidistant from, because for some reason I've got centroid in my mind, and we're actually doing circumcenter, and just trying to get it all together on this Sunday afternoon. All right, let's move on. All right, let's see. We go with number 2. All right, circumcenter. Okay, triangle BCD. Okay, so I gotta find G, D, B, C, E, H, F, D, and C, D. Okay, let me just go through here and see what I've got so far. Okay, well, if BD is 24, I know the left and the right are both 12. Okay. If CE is 7, that means BE is 7. Okay, if the distance from the angle to the circumcenter is 13, that means CH is 13 and DH is 13. Oh, look at a 3 right there. I'm going to do the Pythagorean theorem again. Let's see if that helps me find anything. All right, so GD, I have that. That's 12. Okay, good. B to C will be 14 because 7 on the left and 7 on the right is 14. E to H. Where's E? Okay, E to H. Okay, don't have that one yet. I'm going to do the Pythagorean theorem to find it. FD. FD. I don't have that one. I'm going to do another Pythagorean theorem to find it. CD. I'll have to double to find CD. Okay, darn. All right. I don't have much of a choice. That's all I've got. All right, so I'm going to do EH first. EH. E to H. Is that segment in that right triangle. Now, knowing that I have a 90-degree angle makes 13 the hypotenuse. 7 is the leg I do have, and I'm trying to find EH, which is the other leg. So I'm trying to find EH. Plus 7 squared equals the hypotenuse, 13 squared. A squared plus B squared equals C squared. C is always the hypotenuse. All right, so I'm going to subtract 7 squared to the other side. Helps turn the calculator on. I got a 120. Don't forget to square root. All right, so it looks like EH is whatever the square root of 120 is. Okay, it's approximately, all right. Now, if you're having issues rounding, remember I told you gotta always look behind the tens place, but that's a 5, which makes the 9 round to a 10. So this will be a 0. I'm going to carry my 1 to make that an 11. So it'll be 11.0. Now, it is not straight up 11.0. It is approximately 11.0. So I have to put an approximation sign to show you that it's actually not straight up 11. So it's approximately 11. All right, so E to H, that's approximately an 11. Okie dokie. All right, F to D. F to D is that right there. And again, I'm going to do another Pythagorean theorem. Remember, 13 was my hypotenuse. So changing triangles, that's the distance from the centroid to the angle. It's still a 13. But this time I'm trying to find FD. FD squared plus 3 squared is 13 squared. All right, I'm going to subtract 3 squared to the other side of the equal sign. So 169 minus 9. And then square root that. All right, it's like approximately 12.6 because the number behind is a 4 that does not change the 6. So it's approximately 12.6. Now that's F to D. F to D is approximately 12.6. Now they want CD. Well, if the lower part is 12.6, so is the upper, because remember, F is the bisector of CD, because a circumcenter is made by 3 perpendicular bisectors. So you can either add this or just hit times 2 on the calculator. Times 2. CD is 25 point. Now that 9 rounds that 2 to a 3. 25.3. All right, you guys, there is number 2. Last one on this part 2, because we're getting into almost 14 minutes now. Number 3. Okay. So M is a circumcenter. Move this down. I'm getting off my page here. All right. So let's see. If G to G to J is 31. H to J is 31. Have a 30. That means GL is also 30. I think that's a 23. That's M to K. 14 is J to M. They want G to I first off. Oh, that's an easy one. G to I would be 30 and 30 is 60. They want M to H. I'm going to do the Pythagorean theorem. if you are sitting there going, girl, how do you know that? Well, when you have a circumcenter, all of these triangles are right triangles. And the distance from the circumcenter to the angle is going to be the hypotenuse. So the distance from M to H is my hypotenuse, which is C. Now this is an addition Pythagorean theorem, so 14 squared plus 31 squared. Don't forget to square root the 1,157. Square root that number. And it's approximately 34.0. Not 34 on the dot, by the way. Don't forget that's what we were finding, MH. So it's about 34. Okie dokie. 34. Which means that now that I know MH is 34, I also know that MI is 34. And G to M is 34. Approximately, anyway. Well, that gets me this one. And I still need IK right here. And I still need HI, which is the double of IK. All right, and I got to do another Pythagorean theorem. And it doesn't really matter which triangle you choose to look at. Either way, the 34 is the hypotenuse. And I'm looking to find HK, which will be the same thing as KI. So you could have looked right there if you wanted to. Doesn't really matter. They're the same thing. X squared plus 23 squared is 34 squared. Same numbers over here. 23 squared, 34 squared. All right, everybody, subtract 23 squared to the other side. So 34 squared minus 23 squared. And don't forget to square root the 627. That's about 25.0. So what you just found is both HK and IK. HI, you can either add those or just 25 times 2 would be 50. So 25 and 50. All right, you guys, I'm going to stop this part 2 right here. Go down to the description to go to part 3, which is what's coming up next. Still in the same lesson.